continue what we have learned. Okay, so first of all, if you try to look at the slide that we have here, previously we have learned that we have need to include the three parts in creating a user defined functions. Remember that we have to declare, we have to call, or even we need to define the function. But I'm going to show you the alternative way of creating the user defined functions as shown in this slide here. Okay, so let me use the pointer here. This is the case that you can write a function in another way is that you can try to include the function definition. I try to move the function definitions before the main function. Then after that, only you proceed to call the function in the main function. So you might ask me why we can do so, why we can just skip the function declaration and then write the function declaration and definition at the same time. Remember the concept of function declaration. We want to tell the compiler what is the return type, what is the function name, and how many parameters that we are going to parse down, what is the data type of the parameters we are going to parse down to the function, right? So that's why if you try to write the function definition first, actually from the definition, it already tells the compiler what is the return type, void, what is the function name, addition, how many parameters we pass down, 2 parameters, what is the data type of the parameters we are going to parse down, that part here. So that's why you can choose to write a function definition first, and then after that, only continue to the main function and do the function call in the main function. Okay, then I have discussed some examples to you right just now, talking about how can we try to do the function definitions, how can we try to solve the problems by using the user-defined function. So again, I also provide the code in Java version. Actually, the concept is totally same, and then this is used for your reference later on, right? And then we will move on to the next slide here. So back to our examples that we used just now, remember that we just focus on finding the addition of 2 numbers, and then we just want to pass down the 2 values to the function, and then after that the function is going to help us to find the summation of the 2 values and print out the answer directly. This is a flow, right? And then this is what we have just now. We try to pass down the A and B, which is 36.5 to X and 22, the Y, the second argument here. So actually, this is what we call it as the pass by value technique here. We can know that we just focus on passing down the values, 36.5 pass to X, 20 pass to Y here. So there are 2 new concept name here that I want you to remember. The first one, if let's say this A, B here, these are the 2 arguments that we want to pass down to the function. These are the 2 information I want to pass down to my function. So these 2 arguments, we will call it as the actual arguments. Their meaning is that these are the arguments that I'm going to parse down to the function, all right? Then after that, inside this addition function here, this X and Y are going to be the arguments that will receive the value, right? X is going to receive 36.5, Y is going to receive 20 here. So these arguments inside the function is called former argument. So don't confuse, actual means those arguments passed down to the function, and former arguments means those arguments, there's variables in the function. Okay, so what I want to mention about this 2 name here is that just now we know that we just focus on passing down the parameters by values. So actually the concept behind is that what this A and B are the actual arguments in the main function, and X and Y are the former arguments in the addition function. Okay, so the real concept behind is that when we try to pass down the parameters, pass down the values to the function, actually a copy is made. A copy of 36.5 is made, and then try to store it in the variable X. And then a copy of the value 20 is made and then store in the Y variable. So that's why I put the word here, value copy. We try to make a copy of the values and then store in the X and Y, these 2 former arguments in the function. Okay, so all these actual and former arguments A, B, X, Y, they are all different variables stored in different memory locations. Basically, you can think that they are all different variables, right? So if let's say any changes made to the former arguments here, if let's say you try to change the value of X and Y, actually it won't affect the actual arguments value. It will just try to make the changes to the own former arguments, the X, Y in the function only. That's how it actually works. So we try to use an example to show you that how this pass by value technique works. Okay, so for this case, I still use back the addition code here. Let me back to our code. All right. So we have here. Okay. So for this case here, again, function. All right. So reference. Maybe I just put. Let me just try to make some changes here. All right. Okay, so if you look at here, we have the function declaration, function call, function definition. You should be able to remember all the concept right now. And then after that, we try to pass down these two values A and B to the function call, right? So 36.5 parsed to X, and then the 20 will be parsed to Y. Then after that, the statements inside the addition function is executed. It's going to print out what is X plus Y, which is 56.5 here. Then you see the difference is that we try to make a change to the X value inside the addition function. I just try to change it. I want to update the X value from 36.5 to 50. Then after that, remember, once the function done its job, we are back to the main function. Then now it's time for me to ask, what is the current value stored in this A variable, and what is the value currently stored in this B variable? Okay, so you can say that if let's say I try to run it first, I'm going to show you what is the final value stored in this A and B, then you can see the value of 36.5 and 20. So why? Because this is the pass by value technique, which means that we just focus on passing down the value. So any changes made to the former arguments inside this function is not going to be reflected in the main function. It's not going to be detected outside the function here and including the main function. All right, so eventually, if you back to the main function, it will still find what is the current value stored in A. So it will still remain as 36.5. What is the current value of B? It should be 20. So this is the idea of parse by value technique. It will just focus on pass down the value. It won't bring back any updated value. Then after that, we move on to the next slide. So of course, there is another technique used to pass the parameters by using the reference. Just now we talk about pass by value, right? We just focus on passing down the value. So this is the second technique used to pass down parameters to function. The difference of this technique is that this technique is not going to passing down value. No, it is going to pass down the address of the actual arguments to the former arguments. So it's not passing down values, but instead it passes down address. So do you know what is address? Address means that the place where the variable is stored in your computer RAM. This is what we call as address. Okay, so since we are passing down the address, so both the actual arguments and former arguments, they are actually referred to the same memory location, which means that this A and this X, they are stored in the same location. They're actually referring to the same value stored in the same location. And then for the B and Y, they are actually the same, referring to the same value storing in the same location. Okay, so if let's say, if there is some changes made to the former arguments, for example, I try to make some changes to the X or Y here, these changes is going to be reflected in the actual arguments because they are actually storing in the same location, right? So any changes made to X is actually will be detected for A. Any changes made to the Y, it will be detected for B. Okay, then I want to discuss two examples to use so that you know how this pass by reference actually works. So let us look at the sample code that we have just now. Okay, so what we have just now is that because we just passed down the value, it's not going to bring back any updated value. But if let's say I want to use this pass by reference tanning, what you need to do is that you just have to include one thing here called the reference parameter. Okay, you can see that I put the ampersand sign here. This is what we call it as a reference parameter. So again, if let's say I want to pass down the addresses of two arguments A and B, so of course you have to include the reference parameter for both these two arguments here. And then don't forget your header file. Your function header as well. You have to include a double ampersand here. Okay, so this is what you need to include the reference parameter in the function declaration as well as the function header in your definition. So what does this mean actually? This means that we are passing down the address, right? And then both the A and X, they refer to the same address, same value. B and Y, they will refer to the same address, same value. Okay, so right now we try to call the function. The first thing, of course, it will pass down 36.5 and 20. But if let's say you have included the reference parameter here, what does this mean? Okay, so if you include the reference parameter here, it means that this X is going to store the address of A, and this Y is going to store the address of B. Okay, so of course, the first thing is that A is going to the first one, the pointer X is going to start at 36.5, and then the Y pointer is going to start the value of 20. It's fine. And then after that, we will just proceed to execute the statements. This is going to print out the X plus Y, which is 56.5 here. Okay. And then we try to update the value of X inside this addition function. So the X changed from 36.5 to 50. Remember, in this function here, the X value, I put the pointer here. This means that this is the X, the value stored in the X address here. Okay, so actually the value has changed from 36.5 to 50. Okay, and then if let's say you use a reference parameter here, remember that any changes that you have made to the former arguments in this addition function is going to be reflected outside the function, including the main function here. So 50 will be bring back to this A variable here. If you try to print out, it should print out the value of 50 right now. Okay, so I try to run it. Then you can see the latest value stored in A and B variables are 50 and 20. Okay, but including the reference parameter in just like function declaration and function header, just these two parts, then you can see I can bring back the A and B values. Why? Because both of these arguments, they are referring to the same value in the same address. So any changes you made inside the function can be detected. It can be reflected inside the main function here. A simple way to remember this technique is that any value you pass down, you are able to bring it back. Okay, so we just try to look at the next example. Let's say I want to do some swapping. I have two variables. I have just declared two variables, A equal to 10, B equal to 20. And then what I want to do is that I try to call a swap function. Swap function means that we try to swap the two values, which means that eventually the A will take the value of 20 and then the B will take the value of 10. Okay, so this is how we actually use the reference parameter to bring back the updated value of A and B. Again, let us try to look at the coding here. So, okay. So for this case here, this is the function declaration. The function won't return anything. function name is swap. And then we are going to pass down 2 parameters to the function, right? And then these 2 parameters are integers basically. And we have included the reference parameter here. What it means? It means that we are going to bring back the updated value, right? And then after that, we have declare these 2 variables a equal to 10, b equal to 20 here. And then of course, if you want to print out the value of a and b, it should be 10 and 20. This is the values that store in both a and b earlier. Then we try to call the function. This is how we call the function. This is a function name, and then this is a parameter list, right? We are going to pass down a, b, 10, and 20 to the function. So we are going to pass down a equal to 10 and b equal 20 to the function, pass down the function to the function. So when the function is being called, so we know the control we pass to the swap function here. So for this case, we know that the x is going to store the address of a, the y is going to store the address of b. Okay, so the value stored in this x is going to be 10. The value stored in this y address is going to be 20. It's clear. We just pass down and then start in this both x and y addresses. Okay, and then we are going to do swapping. This is the 4 statements that we have included here to do some swapping, right? So we have declared a local variable, which means that this temp variable can only be used in this swap function here. And then after that, we try to do some assignment. So temp equal to x. So what is the x right now? 10. So we have temp equal to 10 here. Okay, and then after that, what is the x equal to y? So what is a y right now? It should be 20, so x equal to 20 here. Then after that, y equal to 10, so y is equal to, so what is the temp right now? It should be 10. So you can see that after executing all these 4 statements here, the x value has changed from 10 to 20, and the y value has changed from 20 to 10. Okay, remember again, if you include the reference parameter, we are going to bring back the values, right? The x now has changed to 20, so it's going to bring it back here, a equal to 20 right now. And then the y here, the value is 10, so it's going to bring back the value here, so the b is equal to 10. Okay, so after you done the swapping and then we try to print out what is the values of a and b. So the a here is 20 and the value of b here is 10. We can try to run it. Okay, so you can see that before swapping, a equal to 10, b equal to 20. And then after swapping, we have updated both the a and b values. So the a changed to 20 and the b would change to 10. All right. Okay, so you might give me a question is that when we should use this pass by reference technique, all right? Why I can't just use the return statements that we learned earlier to return back the value? So if let's say your function is a value returning function, and then you want to use the return statement to return back the result to the function caller in the main function, it can be done only when you want to return one value. Remember, when you have the return statement, then you can only return one specific value, one result. But if let's say for this case here, you want to actually return back more than one value, I have x and y, the values that I want to return back to the function caller in the main function, then we can't use the return statement anymore, right? So you can use the reference parameter to help you. Just need to include this reference parameter ampersand here in your function declaration and the function header in the definition. Okay. Then we will proceed to this part here. So just now we have learned that we try to declare and define the user-defined functions. And these are the local variables that we have learned. Local variables means that all the variables declare inside a particular function. For example, A, B, result, these are the 3 local variables belong to the main function. And then X and Y, these are the 2 local variables belong to the addition function. So all the local variables, they can only be recognized in their own function. You can't just try to print out the values of X and Y in the main function. Now, this is not allowed to do so because they won't know what is X, what is Y, okay? And then I want to show you another case talking about the global variable. When you talk about the global words, which means that this variable, it can be used globally. What does this mean globally in your program? Which means that this variable, it can be used anywhere in the program. It can be used in the main function. You can see that I use it in the main function, or you can use it in the addition function, the result here. Okay, so for this case, let us have a quick look on the coding part here. So if let's say I have tried to use the global variable, and then after that, we have called a function. Of course, these are the function call and then passed out 36.5 and 20 to the x and y here. And then inside the addition function here, we have the global variable result equal to x plus y, which is result equal to 56.5. Okay, then be careful, the return type is void, which means that it won't return anything. And then it also don't have the reference parameter here. So how is it going to return back the result? Remember that this is a global variable. So once the function does its job, it back to the function caller here, and then it pass back the control to the main function. The idea is that it will use the cout statement to print out what is the value currently stored in this global variable result here. Of course, we know the result value right now is 56.5, right? So that's why it can print out the value of 56.5. So this actually concludes that for global variable, you can access it anywhere. Once the value is updated, then you can detect it. You can just print out the value of the result in the main function. We can just prove it. I try to run it. Okay, the addition of two values is 56.5, right? Then we're back to our slide here. So this is the difference between local and global variable for the first, second, and the last points I have discussed just now. I'm going to talk about the third point here. So for the third point, local variable destroy when control leave the function, which means that if let's say your function has done processing the job here, then x and y variables will be destroyed. Okay, and then after that, for global variable, it will destroy when the program is terminated. So if let's say you have declared the result as the global variable, only when you close the whole program, you terminate the whole program, then only the variable is going to be destroyed. All right. So that's the difference between the local and global variable. So now we move on to our sample program. I'm going to discuss with you the 4 sample cases where we will try to use the function to solve the problem. So right now, we try to look at the first sample. We are asked to write a complete C++ program to find the maximum of 3 numbers that are entered as input. So I have shown a sample output here, which means that we are going to ask the user to key in 3 numbers. For example, the user key in 10, 20, and 30 here. And then after that, we are going to use the program to print out the maximum among 3 numbers is 30. Right? So we need to think of how can we solve the problem. Then I'm going to show you this idea here. Let's say we have the main function. This is the main function. And then we need to think of how can we solve the problem. Of course, the first thing is that we need to get the 3 numbers from the user first. Then only we can proceed, right? So the first task, we get the 3 numbers from the user. The second task is we need to call a function. I want to call a function called maximum so that this function can be used to find the maximum among these 3 numbers. Okay, so what we need to do is that we have to decide, is there any information that we need to pass down to this maximum function? Of course, yes, we need to pass down the 3 numbers entered by the user. So that's why I put pass down 3 numbers here. And then after that, we have to decide, are we going to get back any result from this function? Of course, yes. We need to know what is the maximum result, right? So we can try to get back the maximum result using the return statement because we just have one value to be returned back. So we can just consider to use the return statement. Okay. After we done getting back the maximum, then we just proceed to print the result, to print what is the maximum. That's all. Okay, so this is the idea, and then we can start to think. Or if you want to create the functions in the program to solve the problem, of course, remember, we have to include the function declaration, function call, and also the function definition. So for this main function here, I have done declaring all the three variables here, and then I use a cin to get the inputs from the user for the A, D, B, and C. Now we start with the first one, function declaration. For function declaration, we have to decide what is the return type, function name, how many parameters we want to pass down to the function, what are the data type. Okay, so what is the return type? Since we are going to get back the maximum result, right? So if let's say the values are of double data type, of course, the return value should be of the same data type as well, which is double. So that's why I use the double here. What is the function name? We just name it maximum. Of course, you can give it a different name, maybe max. Then after that, parameters. How many parameters that we are going to pass down? We have three parameters. We want to pass down the three numbers keyed in by the user. So this is going to be 3 double here, because 3 parameters, each parameter is of double data type. Okay, so we've done the function declaration, and it's time to move on to the function call. How can we call the function? Remember, to call the function, you just have two ways. Either the function is the void function, then we can just call the function directly. If the function is going to be a value returning function, either we store the return value in a variable, or maybe we just use the cout to print out the value directly, right? So for this case, this is a value returning function, double, which means that the function is going to return something to us. So we can just try to use this cout statement to print out the return value directly. Of course, you can store the return value in a result variable that we have seen earlier. It's fine. Okay. And then what is the function call? Remember, we have to include the function name maximum, and then we have to include the parameters passed to the function. It should be A, B, C. All right. And then we proceed to the function definition here. We have to define the function. Remember the two parts. We have to include the function header. So the function header is something similar to the function declaration, the same return type double, the same function name maximum, and then the three parameters that are going to receive the values from the function caller. Okay, but the additional part is you have to include the argument name X, Y, Z. You can use the same argument name ABC, but actually this, we know, right? The former arguments and actual arguments, they are actually totally different variables start in different location if this is passed by value technique. Okay, and then we will focus on how can we define the function? What is the function body? What are the statements used to find the maximum among these three numbers? So we have to think, how can we, how are we going to solve this question? How can I find the maximum of three numbers? I'm going to show you a simple case first. If let's say I give you two numbers here, how can we find the maximum? We are just trying to do the comparison, right? We will check, is the second value 20 greater than 10, greater than the first value 10 years? So we know the maximum should be the second value, which is 20. But how can we do the comparison between the three numbers? Can we use the same concept? Yes. So what we can do is that we can just focus on comparing the first two values first. If I compare the first two values, 10 and 20, of course, I'm going to get the maximum of 20, right? Because 20 is the current maximum between these two values. And then I will gather 20 here. Then after that, I try to do the comparison again. I try to compare the current maximum 20 with the 30, the third number, and then we will get the maximum of 30 here. Okay, so this is how the statement comes from. We do the checking for the first two numbers, and then after that, we do the checking for the third number. All right, then we're back to our code here. Okay. So we have the three numbers, A equal to 10, B equal to 20, and C equal to 30. And then we done the function calling here. So of course, it's going to pass down 10, 20, 30 to the function. Then after that, it's going to receive back the return value here, right? And then the 10 will be passed down to the first argument X, 20 will pass down to their second argument Y, 30 will pass down to their third argument Z. So after that, we just try to let the first value to be the maximum, the 10 first, and then we will do the comparison. If the second value 20 greater than 10, this is true, right? Since this condition is true, so the statement here will get executed. So currently the maximum is equal to Y, which is 20. And then after we get the current maximum, we'll do the comparison with the third value. So we have, is the third number 30 greater than the current maximum 20? Yes, the condition here is true. So if this is true, it's going to execute the statements here belong to this if statement. So the max will become the third value, the Z, which is 30. Once we get the maximum 30, we will use the return statement to return back the result of 30 to the function caller. So that's why it will return back the value to this function caller here, and then it will print out 30 for us. So let us try to check it. Okay, and the three numbers, 10, 20, 30, and then you can see that the maximum is 30. So this is how we use the return statement to return back the maximum result. Then we move on to the next sample. Write a complete C++ program to determine if an input integer is odd or even using only a function. For example, I'm going to ask the user to key in a value to us, 23. And then we need to use the program to actually provide the information that, okay, this value is an odd value. Okay, we have to provide such information to the user. If let's say the user key in 24, then we should provide that it is an even value to the user. Okay, so how can we solve the problem? Again, we're back to discuss the idea first. Every time before you start do the coding, you have to think of the idea first. How can you solve the problem? Then only you start to do the coding. So for this case, of course, the first task is we will get the number from the user. Either we get 23 or we get 24. Then after that, we will call the function. This is a function, or I will just name it as is odd. This is used to check is the number an odd number or not. Okay, so I will just focus on passing down one value key in by the user, right? So I will just pass down one number. And then after that, will the function return any result to us? If the number is odd, I want the function to return the answer of true to me so that I know that, okay, the answer is true, and then I will just print out it is an odd value to the user. And then if let's say the answer is false, then I get the false answer, then I will just print out it is an even value to the user. So after that, once we get back the result, we will just print out the information needed to the user. Okay. Then we proceed to discuss the three parts again. How can we declare the function? So how can we declare the function? What is the return type? We are going to receive back the answer either true or false, right? So the return type is bool, okay? Because if let's say the function only return the answer of true or false to us, this is Boolean type. So you have to make sure that you use the bool as the return type. Then after that, what is the function name? I just use the is odd here, okay? And then parameter list. How many parameters that we are going to pass down to the function? So I just want to pass down the one particular input entered by the user. So I will just put the one parameter here. And then I use the integer. Okay, so why I put integer here? Remember, for a number, if this is an integer, only we can decide whether this is odd or even. If like 36.5, we are not, we can't able to decide whether this is odd or even number, right? Then after that, I have included the argument name here, X here, but you can choose to include it or exclude it, okay? And then we go to the function call. Again, for the function call, we have to see, because this is a value returning function, just now we know, right? Either we store the return value true to a result variable, or we print out the return value true, but there's no point for us to print out the return answer true or false. So this is a way that we can print out the needed information. We can just try to call the function and then use this function caller as a condition in this if-else statement. Okay, if the function call is called and then the return value is true, then I will print out it is an odd value to the user. Then if the return value is false, then it will just return, it will just proceed to print out the information of it is an even value to the user here. So the return value is pretty important. It's going to decide which information that we are going to show to the user. Then after that, we proceed to the third part, function definition. Again, function header, it should be something similar to the function declaration. Bool as a return type, function name is odd, and then I'm going to parse down one parameter, one integer will be received by the function. So we have integer here. Don't forget the argument name, the x here. Then we have to think of how can we define the function? What is the function body? How can I use some statements to decide whether the number keyed in by the user is odd or even number? Okay, so I'm going to show you some working step here. You can look at this part. If the number is an odd number, for example, 135, if we try to divide by 2, the remainder is 1, right? If the number is an even number, like for example, 2, 4, 6, 8, 10, if we try to divide by 2, the remainder is 0. So you can see that any numbers that we have right now, if you try to divide by 2 and then get the remainder of 0 or 1, then we can decide whether the number is odd or even. So if let's say we try to divide the number, the remainder is 1, we know that this is an odd number, so I will return true to the function caller. If the remainder is 0, then I'm going to return false to the function caller to indicate that the number is an even number. Okay, so this is how you try to program it. For this, this is the modular sign used in programming, which means that it's going to return the remainder of x divided by 2. You can use it both in C++ or Java. Okay, so after that, we will just proceed to look at the coding part here. Okay. So what we have here is that if let's say the user key in value 23, of course, the function call here is going to pass down the value of 23 to the function. And then we are going to wait for the return value, either we receive true or false. Okay. And then 23 will be passed down to this argument here, the x equal to 23. And then we will do the checking. Is 23 modulus 2 equal to 1? So this is a modular sign, which means that is the remainder of 23 divided by 2, is it equal to 1? Of course, yes, right? Because 23 is an odd number. So if divided by 2, then the remainder is 1. So of course, this is true. So if the condition is true, then this statement will get executed. It will return true to the function caller. So true will be returned back to here. So the condition here, this will become true. This is something similar to something like this, right? So the return value is true here, and that's why this statement will get executed. It will print out it is an odd value. Okay, so again, we try to run it to do some testing. Please key in a value 23 here. It is an odd value. Of course, you can try with the even number. Let us try 24. It is an even value. All right. Then we'll move on to the next sample, the sample tree. Write a complete C++ program to generate the Fibonacci number. Each number is the sum of the previous two numbers. So I have actually provided a series of the Fibonacci number here. You can see that if you try to add two numbers, it's going to get the next number, which what we call as the Fibonacci number. 0 plus 1, we get 1. And then 1 plus 1, we get 2. And then 2 plus 1, we get 3. 2 plus 3, 5. 3 plus 5, 8. 8 plus 5, 13. 13 plus 8, 21, 21 plus 13, 34, okay? So on and so forth. This is what we call it as the Fibonacci number. Okay, and then the question asks us to actually get a positive integer from the user. For example, if the user key in 6, which means that we're going to print out the 6 Fibonacci number. So we can count which number is the 6 Fibonacci number. 1, 2, 3, 4, 5, 6. So 5 is the 6 Fibonacci number, and this is the output. Okay, so this is what we want, and then we are going to discuss the idea first. Of course, the first thing, you have to get the sequence number. What is the sequence number required by the user? For example, 6. Okay. Then after that, we will call the function. The function we just call as a Fibonacci. We are going to use the function to find the Fibonacci number according to the sequence number key in by the user. Okay, so for this case, I will need to pass down the sequence number key in by the user to the function to do the calculation, right? So I will pass down one sequence number, one number, just one information. Okay, then after that, how can we get back the result? How can I get back the result of the Fibonacci number? So if let's say I don't want to use the return statement, remember we can get back the result using the reference parameter, the ampersand, right? We can just get back the value, the answer, okay? Then once we get back the answer, then we can proceed to do the printing. Okay, then we'll proceed to here. Again, we discussed the first part, function declaration. What is the return type? Function name parameter list. So for this case here, we know the function name, it should be Fibonacci, the name that I give to it. And then parameters, how many parameters, how many values that I'm going to pass to the function, and then is there any values that I want to get back using the reference parameter? Yes, right. I want to pass down the sequence number key in by the user, and then I want to get back the result. So that's why you can see that in the parameters list here, there are going to be 2 parameters. The first one, integer, is used to pass down the sequence number to the function. But for the second case here, the integer ampersand, this is used, remember, for the reference parameter ampersand, we can get back the updated value. I want to get back the result using this reference parameter. Okay, and then the function is not going to return anything using the return statement, so I just use the void as the return type. Okay, then we will proceed to the function call. So of course, inside the main function, we are going to do the function call in the main function. The first part, we get the sequence number from the user. And then the next part, how can we call the function? Since this is a void function, so we just need to call the function directly, right? We just have to include the function name, the Fibonacci here. And then after that, we have to put in the parameters that we are going to pass down to the function. So what is the parameters that we are going to pass down to the function? The first one, the sequence number, and then the result, because they don't really want to get back the updated value stored in this result variable. All right. Once we're done, we can only print out the final Fibonacci number. Okay, then after that, we'll look at the function definition here. So for function definition, for the header, we have to use something similar to the function declaration. The same return type void, the same function name Fibonacci, and then after that, the parameter list. So you see, the first one, we have integer. The second one, we have integer ampersand here. Remember, we have to include the argument name, right? So this sig number here, this is representing the sequence number. And then the Fibonacci number here is going to represent the result that we are going to bring it back later on. Okay? So we have done for the header for the function definition. And now back to the main part again. How can we define the function? How can we include some statements to find the correct Fibonacci numbers? Okay, so for this case here, let's say if I want to find the correct Fibonacci number. So is there someone open the mic? So, all right, so anyone, if you are opening the mic, please try to mute it. Thank you. All right, thank you. Okay, so we're back to here. We have to think of how can we find the correct Fibonacci number according to the sequence number key in by the user, right? So we try to look at this slide. Okay, you can see that this is the Fibonacci number, the first, second, third, fourth, fifth, sixth. Okay, then you can see that for the first two numbers is going to be default values 0 and 1. So how can we get a Fibonacci number? We just try to add the previous two values, 0 plus 1, get 1. This is the third Fibonacci number. And then after that, 1 plus 1, this is the equal to 2. This is the fourth Fibonacci number. 1 plus 2 equal to 3. This is the fifth. 2 plus 3 equal to 5. This is the sixth Fibonacci number. 3 plus 5 equal to 8. This is the seventh Fibonacci number. Okay, so you can see that we try to add the first and second to get their Fibonacci number. And then after that, we need to update, right? You can see that we try to update their second one to become the first item, and then the Fibonacci number become the second item in order to update the next Fibonacci number. I repeat again, we try to update the second value become the second number become the first number, and then the Fibonacci become the second numbers to update the next Fibonacci number. Okay, so this is the idea. We try to find the current Fibonacci number first, and then after that, we updated the first and second value in order to find the next Fibonacci number incoming. Okay, then we proceed to here. This is how we actually program it. If we try to look at this part, Fibonacci number equal to first plus second, this is the first thing that we mentioned. And then after that, we try to update it. The second become the first, and then the current Fibonacci number become the second. That this is used to update the next Fibonacci number. Okay, then we proceed to back to our code programming here. So let me try to do this one. Okay, so if let's say the user has keyed in the sequence number of 6, we have the 6 here, okay? And then we are going to call the function and pass down the sequence number of 6, and then also pass down the result, right? Did anyone opening the mic again? Try to mute it, thank you. Okay, so if you look at here, you can see that for this case here. All right, so what we have here is that because we pass down the 6 to the function call, to the function here, and then we are going to, because right now the result, we don't have any value yet, right? So later on, we'll bring back the result. Okay, so wait for a moment, let me check. Okay, I hope it's fine now. All right. Okay. So we pass down the 6 to the function call, the function here. So the 6 number is going to start the value of 6. And then after that, for result, because we just passed down the result and I don't have any value yet, later on we'll pass back their updated value starting this result variable. Okay. And then this is the Fibonacci number. Of course, now it should be a question mark first. We don't have any value yet. Okay, so after that, we have here the first one. Of course, these are the two default values that we need to declare first. We have the first is 0, second is 1. And then we have declare a variable count equal to 3 because we are going to find starting from the third Fibonacci number onwards. Okay, and then we'll do the checking here. Is the sequence number 6 equal to 1? Of course, this is false, so we are not going to execute this statement. Okay, and then is the sequence number equal to 2? Of course, this is false. We are not going to execute this statement as well. And then it will just enter the else part here. Okay, so to enter the else part, we have the while loop here. This is where we try to use it to find the exact Fibonacci number. For example, if let's say I have the count, which is 3, currently my count equal to 3, right? Is it less than or equal to the current sequence number 6? Yes, this is true. So if this is true, it's going to find the third Fibonacci number, which is equal to first plus second, which is 0 plus 1 equal to 1. Because currently my first value is 0, second value is 1. Okay, and then after that, we have to update, right? What is the first value right now? the second part, 1 will become the first value, and then the current Fibonacci number 1 will become the second value. Then after that, we'll do the increment to the count variable 3 plus 1 become 4. So when this is done, we're back to the while loop again. Is the current count 4 less than or equal to 6? This is true. And then we'll update the fourth Fibonacci number. So what is the first value right now? 1. What is the second value? 1. So it will become 2. So the fourth Fibonacci number is 2. Then after that, we'll update the first value. The current first is equal to their second value here. And then the Fibonacci number will become their second value here. Okay. And then we'll do the increment to the count 3 plus 1. So now the count is 4. 4 plus 1 become 5. Then we're back to the while loop again. Is 5 less than or equal to 6? Of course, this is true. So if this is true, 3 plus 1, 4. Okay, so let me wait. 3, 4, 5, 3. Okay, so after that, if this is true, and then after that, we will update, we are going to find the fifth Fibonacci number is going to be the first value 1 plus 2 equal to 3. Okay, and then after that, the first will become 2, the second will become 3, and then we'll update it again. 5 plus 1 becomes 6. Okay, then after that, we're back to the while loop again. Is the current count value 6 greater or equal to 6, which is true, right? If this is true, we are going to update their sixth Fibonacci number. So the first is 2, the second is 3, and then we'll get their sixth Fibonacci number, which is 5. Then what is the current first value? 3 will become the first value, 5 will become their second value. Okay. Then after that, the current count is 6. 6 plus 1 becomes 7. So if back to the while loop again, is the current count 7 is it less than or equal to 6? Of course, this is wrong. So this is false, and then it will exceed the while loop. So it will exceed the while loop, and that it will exceed the if else statement as well. Then after that, you see, currently my Fibonacci number is 5. So that's why we have the Fibonacci number 5 here. Remember, this is the reference parameter. We always can bring back the updated value if you use the reference parameter. So the 5 will be returned to the result here. And that's why when you try to do the printing of the result, it's going to find what is the value stored in this result variable is going to be equal to 5. Okay, so I try to run it. Okay, and the positive integer, I try with the 6, and then you can see that the sixth Fibonacci number is 5, correct? So you can try to enter a positive integer, maybe 100, and then you can try to search Google online, what is the 100th Fibonacci number, and then make sure that the output is same as what you have obtained right here. Okay, but sometimes you need to be careful because for this case here, we actually, the Fibonacci series that I gave to you, we start from 0. Sometimes the Fibonacci numbers that you obtain online, they just start from 1. So you just have to be careful of which numbers that you want to find. All right. Okay. Then we'll proceed to the last sample today. So this sample here, we are asked to write a complete program to calculate either the area of a rectangle or a triangle using functions. If we try to look at the sample output that we have here, we will just try to print out an information to the user. Do you want to calculate area of rectangle or triangle? If you want to find the rectangle, you just key in 1. If you want to find the area of triangle, just key in 2. So if let's say the user key in 1, we know that they want to find the area of rectangle. So you have to ask the user to key in the length and the width. Then after that, you will proceed to print out the area of the rectangle. Okay. Once you're done finding the area of rectangle, then you are going to ask the user, do you want to continue? Yes, you just key in Y. No, you just key in AND. Okay, if the user key in Y means that the user want to key in the parameter values to find maybe the area of rectangle, triangle. So we print the menu again, we ask again, do you want to find which area? If the user key in 2 again, so we know they want to find the area of triangle. So I will ask the user to key in the height and the base of the triangle so that later on I will print out the correct area value to the user. Okay, then after that, if the user want to stop to continue, then they just key in end here, then we will just end the program. All right, so now we have few things to do, right? We need to ask the user which one do you want to calculate. Is it triangle or is it rectangle? After that, once they're done, you ask again, do you want to continue or not? So we try to discuss the idea first. This is a main function. Then after that, we will try to provide information to the user, which area that you want to find. So this is the first function that we need to call. We are going to call a print menu function. We'll tell the user, enter 1 to find the area of rectangle, enter 2 to find the area of a triangle. Okay, after we're done providing the information, of course, this is time that we need to get the request from the user. Are they going to enter 1 or 2? Okay, so if the request is equal to 1, of course, we need to call another function, which is this function is used to find the area of the rectangle. So of course, in this function here, because we know this is a function used to find the rectangle area, so we have to ask the user, please key in the length and the width so that you can find the rectangle area and do the result printing. Okay, and then if the request is equal to 2, we just call another function again. It's going to ask them to find to key in the height and the base in order to find the area of the triangle. So this is the flow where we show the menu and then we wait for the user request. Then we decide which functions that we want to call to find the area of the rectangle or triangle respectively. Okay, but now there's a question. How if the user they actually enter an invalid request? For example, the user might just key in the request of 3, 4, or A, B, C, D. So we have to perform some checking here, right? We can't just, if let's say they key in their invalid request, then the whole program just terminated, then this is not a good program. Okay, so we can do some checking in our program. So how can we do that? You can try to use a while loop here. I use a do while loop here because I want to go through all these things first, then only do the checking. Okay, so the idea of putting in this while loop is used to check the validity of requests. If the request is invalid, I will go into here again, show the menu, ask the user their desire, whether they want to find which area. If the request is valid, then I will just show their area and then that's all. Okay, then after that, remember the last step, after they done putting in the correct request, after they done obtaining the area, then we want to ask them, do you want to continue or not? So this is a time where we need to include another do while loop. Okay, once they have done everything, the request is correct, and then we done asking the inputs for the areas, and then we done producing the result of rectangle or triangle, then we will ask them, do you want to continue or not? So the outer while loop is used to check the user intention. Do you want to continue or not? Okay, so this is a flow. And then of course, we are going to discuss about the suggested solution. The solution might be a little bit lengthy, but if you look at here, we try to understand it based on the flow that we have discussed just now. Okay, so I just try to minimize a little bit. Okay, so you can see that I have actually included two do while loop here. The first one used to check the user intention to continue. The second one is used to check the validity of the request. And after that, this is a print menu. We provide the information that we check, right? If the request is equal to 1, we call the function to find the area rectangle. And then if the request is equal to 2, we just call the function to find the triangle area. That's all, right? Okay, and then after that, these are the function declaration. You can see that all the return types are void, which means that they are not going to return back any value. And then after that, this is the empty bracket, which means that we are not going to parse down any values to them. And then we are not going to get back any return value. That's all. Then this is the global variable, which means that we can use it either in the main function or either in the other print menu area rectangle or area triangle function. Okay, so we try to go into the do while loop and see how we can gather sample output exactly. So if you look at here, I have declared 3 variables here. The first one, I have to check the correct request equal to n here. Okay, so I put in here, it means that we just try to assign n to this correct request. It is fine. Then we will do the printing menu here. So we will ask the user to key in the request. If you try to look at the sample output that we have right here, so you can see that the first request is 1. Okay, so I will just key in 1 here. The request is equal to 1. Okay, and then after that, we will check, is the current request 1 equal to 1? Yes, this is true. So this statement will get executed. It will call the area rectangle function. It will back to here, rectangle area here. And then after that, it will ask the user, please key in the length and the width of the rectangle. So we have the length, the user will key in 10 and for the length and 2 for the width. And then it's time for us to find the area of rectangle, which is 10 times 2 equal to 20 here. All right, so we're done finding the area of rectangle. We're back to the function caller again. So now you want to update the correct request, become y. Okay, then since this if statement has been executed, it will just end it, and then we proceed to check, is the request valid or not? So of course, the current correct request y, it is not equal to n, so that's why the condition here is false. If the condition here is false, means that it won't enter the do while loop again. It will just continue here to continue to execute this statement. Do you want to continue? Then of course, the next input key by the user is yes. They still want to continue to find the area of triangle. So the choice is y, and then it will check. So since currently the y is equal to y here, so the condition here is true, right? If this is true, it's going to enter the do while loop again. And then after that, it will proceed to do the checking of the area again. So right now here, we will try to assign n to the correct request again, and then we'll ask the user request again. So the next request that we enter by the user is actually 2. So we have request is 2 here, and then it will check. Current request 2 is not equal to 1, so this is false. It will skip the execution of the statements inside the if statement here. And then after that, the request 2, is it equal to 2? Yes, this is true. It will proceed to call the area triangle function. So once the function is called, it will go to here, and then it will ask the user to key in the height, the base 10 and 2, and then it will find out what is the area of triangle, 0.5 times height times base. We get the answer of 10. Okay, and then after that, once the function done performing its task, it just passes back the control back to the main function here, and then after that, update the correct request become the y here, which means that the current request is actually valid, right? The request is 2. And then again, the correct request, the current y is not equal to n. This is false. It will exit the inner do while loop here, and then it will continue here. Do you want to continue? So now the user don't want to continue anymore. So it will just key in n for the choice. Then it will do the checking again. So currently the n is not equal to y, right? It's not equal to lowercase letter y or uppercase letter y. So this is false, and then it will exit the do while loop and end the program. Okay. So of course we can give it a quick try right now. Let me just show here. So if let's say enter 1 to find the area of rectangle, 10, 2, so you can see the area rectangle is 20. Do you want to continue? Yes. Enter 2 to find the area of triangle, and the height and the base. So the area should be 10, right? Because multiplies with 0.5. And then do you want to continue? No, that's all. Okay. So this is how we actually use the sample, the suggested solution to find the correct area of rectangle and also the triangle, right? So we're back to here, and I think that's all for the second session. Okay, so I hope that you are enjoying the workshop, and if you don't have any questions, then you come back to the main room. All right, thank you, students.
Thank you.
Thank you.